Hello everyone and welcome to my first video. I thought I would just try something new and hopefully some of you will like it. Sometimes it's just easier to show things rather than explain them, so that's really the goal here. In this video I will work with play-by-play data, really just to show how easy it really is. So we'll just get started, and first we'll need to download the data. So for that I'm using evolvinghockey.com. You will need a subscription to download it, but if you're into hockey statistics and analytics, it's money well spent, I promise you. So we'll just go to tools, there, play-by-play query, and here we can download the data. So in this tutorial, or whatever we want to call it, I'll just be working with the 18-19 season, since that's the last full season. So in this exercise we'll just work with shot data, so we'll just use goals, shots, misses and blocks. And of course we'll need the entire season, so we'll just go back here to October. And that's basically it. Now we can just press submit and all shots will come up from that 18-19 season, all regular season shots. So we can see here that it's a pretty big data size with 147,000 shots. So that's it. We'll just download it. I already did that, so instead I'll just open it in Excel. So we'll just go to data, open from text, and I have all of these from all seasons, so we'll just pick the 18-19 season. The important thing here is to just make sure you got it comma separated, and that's it. It will take a few seconds just to open because it's a fairly big data size. So we'll just wait here. Yeah, so that's it. Before we get started, I'll just delete some columns that we are not going to use, and then I'll go through the data afterwards. We can always retrieve these columns when we want to, as long as we got the PBP data, so it's not that important. Yeah, so this is what we're going to work with today, and before we get started we'll just make it into a table so that we can sort in the data, and that's fine. Okay, so what we got here is we got the season, of course, we got each game has a game ID, we have the game date, and every event has a number. So you can see here there's a lot of events not in the data, but that's because we're just looking at the shots. When you got the period and the time of the event, and then we got all the event types here. So those are blocks, goals, misses, shots, and we got the shot types. We can just rename that shot type. And we got the event team, but since we are only looking at shots, we'll just rename that to shooter team. And we want to add a column here because we also want to look at the defending team, so we'll just call that the goaltending team. Then we got the event player 1, which is the shooter when we're only looking at shot data. And we got the event player 2. This can be either the shot blocker if it's on a block shot, or it can be the primary assist maker on a goal. But we'll just be looking at shot blocks. So the first thing we need to do now is to just remove all things from this column that are not shot blocks. So we'll just sort by event type. And remove all non-shot blocks. So we'll just remove these. And that's it. Next column are the home goalie and away goalie. We are only interested in the goalie that actually faces the shot. So we will want to delete half of these goalies, but we'll get back to that later. Then we got the home team, the away team, home score, away score. Not going to use that today, but we will in the next video. Game strength state, also very interesting, just as a filter, so we can look at 5-on-5 data, or we can look at power play data, or whatever we want. Shot distance, shot angle, and this one is predicted goals. This is the expected goals value from evolvinghockey.com. It's non-adjusted, and we got a lot of NAs here. That's because block shots have no expected goals value. So we'll just remove all NAs. And we'll just search NAs. And we'll just make these zeros instead. Simple as that. Okay, so the next thing we want to do is we want to determine if the shooting team is the home team or the away team. So we'll just add a column, call it is home. And that's quite easy to do. We'll just ask the question, is the shooter team the same as the home team? If that's the case, it will come out as a true. If not, it will come out as a false. So that's it. Now I'll sort in this column just momentarily, but before we do that, it's always a good thing to remove all calculations when we're working with this big of a data size. So we'll just copy all of these and insert them as a value. So now we have removed all calculations and it's just left as a false or a true. Then we can sort it. And I'll just rename these so that when the shooting team is not home, we'll just give it a 0. And when the shooting team is at home, we'll give it a 1. Like that. And now we can also add the goaltending team, because we now know if the shooting team is at home. So here we got all shooting teams at home, so we'll just know that the goaltending team must be the away team. So we'll just copy the away team and paste it. And we can do the same with whenever the shooting team is away from home, then the home team must be the goaltending team. So we'll just paste that. And we want to do the same with the goalies. So now we got the shooting team away from home, meaning they are shooting at the home goalie. So we're interested in keeping the home goalie and deleting the away goalies. So we'll just say delete to that. And do the same whenever the shooting team is at home. They are then shooting at the away goalie, so we'll delete the home goalies. Okay, so far so good. We can just add a column here so that we don't have the goalies in two columns, but just in one. So we'll just call that goalie, and we'll just start by copying the away goalies, and then we'll copy the home goalies afterwards. So that's it. The last thing we want to do before we can start analyzing the data is we want to put these event types into separate columns. So we'll just make 4 columns at the end here. Just insert. And we'll call them goal, shot, miss, and block. And we'll just start by giving them all the value of 0. Oh, and we need all shots. So, like this. And then we'll sort by event type. And find the goals. And give them the value of 1. We'll do the same for the shots. But we'll include the goals because a goal is also a shot. Make these into 1s. And we'll do the same for the misses. Oh, and the same for the blocks. So now we are ready to start analyzing the data. So we'll do that by making a pivot table. So we'll just go to insert, pivot table, say that's okay. And now we can start off by looking at shots for on a team basis. So this is the shooter team. And we can just add the columns here. Goal, shot, misses, blocks, and expected goals. So here we got the number of goals for Anaheim on this many shots, and this is the unadjusted expected goals. So we're also interested in including a couple of filters here. So we can filter it by strength state. So we can, for instance, just look at 5-on-5 data. So now you got Anaheim scoring 136 goals 5-on-5 on 148 expected goals. So just for the fun of it, we can go to Evolving Hockey, just test this out. So we'll just search team tables, 5-on-5, no adjustment, and we're looking at the 18-19 season, and we're looking at shot totals. So we should see the same amount here. So goals for 136, that's the same. The expected goals 177.59. I hope that's the same. I think I looked at the wrong thing. Expected goals for 148.32, 148.32. So we can take that as a test that what we did so far is correct. Okay, so far so good. We can add is home to the filter, so we could look at home data separately or away data, or we could just look at all data. And we're looking only at shots for, goals for. On a team basis, we could look at shots against, then we'll just focus on the goaltending team, or we could look at individual shots. So here you got, for instance, Barkov having scored 18 goals on 13.8 individual expected goals. Or we could, of course, just focus on the goaltender, and it's the same principle. Yeah, so the last thing I want to do here today in this video is I want to look at shot types, because this is interesting, because this is not something you can easily find anywhere else. So you will need to look at play-by-play data to find this kind of information. So we'll just add that. Here you see how many goals has Anaheim scored on backhands, on deflections, on slap shots, and so on. So for this exercise, we'll just look at league-wide trends. So we'll just remove the team. And now we see how many shots are scored on the backhand in the entire league in the 18-19 season, 5-on-5. Okay, so we'll just try and copy this and do some things with that. So we'll just add a new sheet and paste it. So we could just add a few things here that we want to look at. We could look at shooting percentage, or Fenwick shooting percentage, miss percentage, block percentage. We could look at type percentage. How many of the total shots are backhand shots? That's what I mean. And we could look at the expected goals per Fenwick, which is the same as the expected Fenwick shooting percentage. So we can just calculate these quite easily. Say shooting percentage is the same as goals divided by shots times 100. Fenwick shooting percentage is the same as goals divided by shots plus misses times 100. And miss percentage is something I have defined as misses per Fenwick, so it's just misses per shot plus misses times 100. And block percentage is the number of blocks per Corsi, so it's blocks divided by shots plus misses plus blocks times 100. So type percentage is the total amount of shots divided by, or the total amount of backhand shots divided by the total amount of shots. So it's just shots plus misses plus blocks divided by 63193 plus 24255 plus 29706 times 100. So we see here that 6.6% of all shots are backhand shots. And finally, we'll just look at the expected goals per Fenwick. So that's just per shot plus miss times 100. So when we're looking at league-wide trends, we should see a great correlation between the Fenwick shooting percentage and the expected Fenwick shooting percentage. That means that the expected goals model explains shot types correctly. So now we can just copy all of these. And we got some interesting data that is not easily found anywhere else. So maybe what's interesting is that the wrist shot percentage is almost 57%. So more than half of all shots taken are wrist shots. So if you looked at the type percentage over time, you will see that the slap shot percentage is going down and the wrist shot percentage is going up. But now we got only the 18-19 season. So I think that's it for this video. I hope some of you learned something. So that's it for now. Goodbye.